The age of blind tank battles was ending. Across Europe's frozen plains, thousands of Soviet T-72s had once thundered in overwhelming formations, steel beasts moving as one against any obstacle. Commanders trusted sheer mass, armor over accuracy, numbers over nuance. But Western engineers had seen the cracks. They understood that warfare was evolving, and a revolution in fire control was about to rewrite every rule. Imagine a Soviet platoon cresting a ridge, the air sharp with cold, treads crunching over frozen mud. Turret crews squint against the winter sun, eyes scanning for targets, hands gripping controls that demanded skill and instinct. On paper, they were unstoppable. In practice, chaos reigned. Mistimed shots, slow target acquisition, and misjudged distances turned tanks into stationary death traps. In these moments, numbers could not save lives. Precision would. And of the West, advanced fire control systems were their answer. Gyroscopic stabilization, laser rangefinders, ballistic computers. Technologies that transformed aiming into near-predictive science. One skilled gunner could now match the effectiveness of a dozen uncoordinated Soviet tanks. Observation perimeters widened. Shots that once required guesswork now struck with certainty. The battlefield shifted from brute force to calculated lethality. Consider a Western Leopard 2 or M1 Abrams advancing under artillery fire. Crew members, fully aware of their system's capabilities, tracked multiple moving targets simultaneously. The gunners display overlays distance, speed, and wind, computing trajectories in seconds. Meanwhile, the commander surveys the horizon, issuing orders informed by real-time calculations. What once demanded instinct now demanded precision, and precision was deadly. Soviet doctrine faltered in the face of this new reality. Massed armor, designed to overwhelm through numbers, became vulnerable to smaller, technologically superior units. The T-72's weak fire control and optical limitations were exposed. Crews struggled to estimate range under smoke and debris, shells falling short or overshooting targets. Western units exploited these weaknesses, engaging from beyond effective enemy fire. One calculated shot, one perfect strike, could halt an entire formation. This wasn't theory, it was reality. In exercises and border skirmishes, Western forces demonstrated the decisive edge of fire control. Where Soviet armor had relied on aggression, Western tanks relied on information. The shift was subtle to the untrained eye. No massive explosions, no heroic charges. Yet for those in the thick of it, survival depended on every fraction of a second, every micro-adjustment of gun, turret, and crew. The balance of power had changed quietly, but irrevocably. For Soviet strategists, the implications were stark. Tank design, training, and tactics all had to be reconsidered. Speed alone could not compensate for inaccuracy. Numbers could not replace control. The battlefield demanded integration of technology, discipline, and foresight. Without it, the mass tanks that once dominated Europe were vulnerable, exposed, and ultimately obsolete. By the end of the exercise, the conclusion was clear. The era of blind Soviet dominance had ended. The fire control revolution did not just enhance tanks. It redefined them. Warfare was no longer about overwhelming mass. It was about information, precision, and timing. One Western crew could neutralize 10 Soviet tanks. One mistake could doom an entire formation. The rules had changed, and those who failed to adapt would be left behind in history's cold steel shadow. The age of blind tank battles was over, and what the West had unleashed was not just technology. It was inevitability. By the early 1980s, NATO commanders weren't just thinking about numbers. They were thinking about speed, accuracy, and survival. The Soviet Union still relied on armored waves, but Western engineers had learned a crucial truth. Technology could multiply lethality in ways raw numbers never could. The Leopard 2, the M1 Abrams, and their kin were no longer just tanks. They were sensors, computers, and weapons fused into a single machine designed to dominate before the enemy even fired a shot. Picture the M1 Abrams rolling across a German training ground, dust kicking up from its treads, turrets swiveling with mechanical precision. The crew inside is calm, almost clinical. The gunner's eye aligns with the target, a faint red laser tracing the enemy vehicle's outline. The ballistic computer crunches wind, distance, and barrel temperature in milliseconds. The loader secures the next round, hand steady. Outside, the commander watches, scanning multiple sectors. One tank. For trained crew members, dozens of potential Soviet targets, and only seconds to act. The difference between life and death is microseconds, and the system delivers. Meanwhile, Soviet T-72 crews struggle under outdated fire control optics, manual range finding, and instinct-driven targeting. Smoke, snow, or terrain irregularities can scramble estimates. Even seasoned crews must guess at distance and speed, often firing multiple shells blindly, hoping one lands. By contrast, a Western tank can engage a moving target at ranges that the Soviets can barely measure. The battlefield becomes a theater of controlled chaos for the unprepared. Exercises at Grafenwohr and Hohenfels demonstrated the new reality with brutal clarity. Leopard 2s and Abrams could track multiple moving targets, fire accurately on the first shot, and adjust for conditions in real time. Soviet armor, mass and columns, was consistently outmatched, engaged before reaching effective range, destroyed in seconds. The lesson was unambiguous. Training, technology, and fire control integration could replace overwhelming force. But the change wasn't just mechanical, it was psychological. Soviet commanders realized that once their formations were under Western observation, uncertainty became lethal. Hesitation, misjudgment, and reaction time determined survival. One precise strike from a Western tank could disrupt an entire offensive, forcing retreats, recalculations, and even internal panic. Numbers could no longer guarantee success. Confidence could not substitute for capability. The West engineers didn't just create better tanks. They rewrote the rules of armored warfare. Turrets could stabilize on the move, gunner sights provided instant target data, and fire control computers ensured first-round kills. Even terrain that once slowed targeting, rolling hills, forests, urban rubble, no longer mattered. Western crews trained to trust systems, and systems rewarded that trust. Every training exercise reinforced a simple truth. The side with precision dominated the side with mass. Soviet doctrine, built for overwhelming the enemy, now revealed its fragility. Mass tanks could no longer advance unchecked. Even elite crews were vulnerable to technologically superior opponents. Tactical theory had shifted. Western tanks were no longer reactive. They dictated engagements, control ranges, and leverage information like a weapon. The battlefield became a test of adaptation. One Western gunner could neutralize a formation of Soviet tanks before the enemy understood the threat. One miscalculated Soviet maneuver could be fatal. The rules of armored warfare, written in decades of Cold War assumptions, were now obsolete. Precision, technology, and crew integration had replaced quantity, mass, and blind courage. By the time exercises concluded, NATO had proven the point. The future of tank combat was no longer Soviet waves versus brute strength. It was Western fire control integration and deadly precision. The era of overwhelming numbers had ended, and the battlefield had entered a new age, one dominated not by mass, but by microseconds, optics, and computing power. The fire control revolution didn't just change tanks. It changed warfare itself. And the Soviet Union, for all its might, would never adapt fast enough to reclaim dominance. By the mid-1980s, the Soviet Union could no longer ignore the mounting evidence. NATO's tanks weren't just faster or better armored. They were smarter, integrated, and lethally efficient. Soviet generals studied the M1 Abrams and Leopard 2 with a mixture of fascination and dread, aware that their doctrinal foundation, mass, momentum, and numerical superiority was under threat. They had built the Red Army's Armored Corps for blitzkrieg-style shock, but technology now dictated a new battlefield reality. Precision could neutralize quantity, and systems could outthink human reflexes, i.e. training grounds from the plains outside Moscow to the forests of Belarus. Soviet crews ran exercises designed to simulate Western tactics. They adjusted gun sights, practiced rapid maneuvers, and simulated firing at moving targets. But no amount of repetition could fully compensate for outdated fire control systems. The T-72s and T-80s lacked computerized stabilization and first-round accuracy over long distances, leaving crews vulnerable to the first lethal strike. Imagine a Soviet tank column advancing through misty terrain, engines rumbling, crews tense, aware of NATO observers watching every move. The lead tank's gunner tries to estimate the range visually, factoring in slope, wind, and target movement. Seconds stretch. A Western Abrams and a concealed hull-down position locks onto the first T-72. The gunner's computer compensates for the drift temperature and speed. The round fires, and the lead Soviet tank is disabled before anyone can react. Chaos ripples down the column. Hesitation spreads. Confidence erodes. A formation built on audacity and volume collapses under precision. Soviet engineers worked tirelessly to bridge the gap, experimenting with improved optics, laser rangefinders, and reactive armor. But innovation was slow, constrained by bureaucratic inertia and the sheer scale of production. Modernization programs struggled to reach every unit. Meanwhile, Western crews practiced relentlessly, refining their coordination, firing on the move, and trusting the systems they had built into the tank itself. The disparity wasn't just technological, it was cultural. Western crews were trained to integrate technology into instinct. Soviet crews were trained to react under pressure with limited support. Cold War war games and exercises exposed harsh truths. Simulated NATO ambushes revealed staggering kill ratios in favor of Western armor. One platoon of Leopard 2s could theoretically neutralize a full Soviet company before it reached effective firing range. Massed armored assaults, the bread and butter of Soviet doctrine, were now vulnerable to a single well-positioned opponent. The tank battlefield had shifted from a physical contest of numbers to a battle of information, reaction time, and precision engineering. Psychologically, this shift was profound. Soviet commanders understood that a single mistake could cascade, destroy morale and effectiveness. Even elite tank crews felt the pressure. One misread range, one delayed shot, and entire formations risked annihilation. Fear was no longer abstract. It was quantifiable, built into every engagement. NATO didn't just threaten tanks. It threatened decisions, timing, and judgment. The battlefield had become a crucible where hesitation was fatal. Yet, in Moscow and Kiev, the response remained partial, fragmented. Soviet officers debated upgrades, questioned tactics, and sent limited technology to frontline units. But by the late 1980s, the writing was clear. The fire control revolution had rewritten the rules of tank warfare. Mass alone could no longer guarantee dominance. Precision, integration, and crew synergy had become the decisive factors. The lesson was stark. The Cold War's armored balance was no longer static. Soviet numerical superiority was undermined by Western technological supremacy. Tank battles, once predictable and doctrine-driven, now demanded adaptation or risk irrelevance. The Red Army could rebuild, but the battlefield had already changed. The first mover advantage was no longer measured in units. It was measured in microseconds, citing accuracy and computational speed. For NATO planners, the implications were clear. The future belonged to those who integrated men, machines, and systems into one lethal whole. For the Soviets, it was a sobering realization. The age of massed armor charges, unchallenged by technology, was over. The battlefield had evolved, and only those who evolved with it would survive. By the late 1980s, the theoretical advantages of Western fire control systems were no longer abstract. They were being put to the test in sprawling NATO exercises across West Germany and the plains of Northern Europe. These weren't games for spectators. They were rehearsals of the apocalypse of armored warfare, simulations where human lives, though absent, were represented by tanks, crews, and doctrine. And every simulation told the same story. Technology was rewriting the rules of survival on the battlefield. Picture it. A cold dawn, frost gripping the ground, armored columns moving like metal serpents across training ranges. NATO's Leopard 2s and M1 Abrams are spaced deliberately, each hull down behind a slight rise of terrain, sensors scanning for targets invisible to the naked eye. Across the field, T-72s and T-80s advance in textbook Soviet formation. Shoulder to shoulder, engines roaring, officers shouting commands through radio static. Confidence flows through the ranks. Decades of training tell them mass will win. But doctrine meets reality in the form of microseconds and millimeters. The first encounter is swift. Western tanks, using advanced laser rangefinders, lock onto targets before the Soviet crews can acquire sights. Computers stabilize guns against recoil and motion, calculating elevation, and led with precision that humans can only approximate. A single round strikes, and AT-72 is immobilized. Another follows, and chaos ripples through the Soviet formation. Hesitation spreads. Gunners fire without coordination. Their training unable to compensate for what their eyes cannot see, and their hands cannot calculate fast enough. Observers note something alarming. Kill ratios favor NATO units by staggering margins, even when outnumbered. Doctrine had assumed mass compensated for imprecision, but technology had inverted the battlefield equation. A smaller, well-coordinated force with advanced fire control could eliminate larger formations before they closed effective range. The tactical calculus of the Cold War had shifted. But it isn't just numbers. Psychology is at play. Soviet crews report moments of paralysis, seconds of fear where hesitation meant death. Officers try to rally their troops, but every movement is anticipated, every position compromised. The battlefield, once a contest of courage and audacity, has become a theater of calculated efficiency and lethal anticipation. One misjudged move can cascade into total collapse. Meanwhile, NATO crews operate with a terrifying rhythm. They move, fire, and adjust almost instinctively, guided by systems that augment human reaction time. Night vision, ballistic computers, and laser targeting make long-range engagements deadly precise. Crews are trained not to hesitate, trusting their technology to calculate trajectories humans could never manage under fire. The line between man and machine blurs, and survival depends on embracing the system rather than relying on instinct alone. The Cold War exercises also revealed doctrinal weaknesses. Soviet reliance on visual estimation and manual calculations leaves them exposed to ambushes and flanking maneuvers. Terrain that would once conceal or protect armor columns now offers little defense against systems that can track, compensate, and strike through dust, fog, and smoke. The lessons are clear. Without modernization, numerical superiority is meaningless. These war games aren't just technical experiments. They are psychological conditioning. NATO leaders understand that demonstrating dominance in simulation sends a message beyond the range of tanks and artillery. It signals to potential adversaries that aggression carries unacceptable risk, that even the first strike can be neutralized with surgical precision. Fire control is more than a tool. It becomes a strategic weapon of deterrence that by the end of the 1980s, the evidence is undeniable. The battlefield has evolved. The Cold War's doctrine of massed armored assaults has been replaced by a new reality. Precision, information integration, and human-machine synergy determine victory. The war may never come, but if it does, the side that embraces these principles will dominate. Those who cling to old doctrines will pay the cost. And in every NATO briefing, the same phrase recurs. Fire control doesn't just kill tanks. It kills assumptions. By the early 1990s, the lessons of advanced Western fire control systems had moved beyond training grounds and test ranges. They had entered the war rooms of governments and military planners. The Cold War was ending, but its armored legacy was being rewritten in real time. NATO exercises and satellite reconnaissance had demonstrated an uncomfortable truth. Mass Soviet-style armor formations were obsolete against precision and speed. This realization reshaped not just tactics, but strategy itself. Defense analysts in Washington, Bonn, and London poured over after-action reports and telemetry data. They didn't see tanks destroyed in sand or snow. They saw the death of outdated doctrine. Planners understood that if conventional war broke out in Europe, numerical advantage no longer guaranteed survival. Instead, the focus shifted to intelligence integration, precision targeting, and rapid mobility. Battles were no longer fought on the map alone. They were fought in microseconds, guided by human-machine synergy and advanced targeting systems. The ripple effects were immediate. NATO member states began investing heavily in sensor fusion, night vision technology, and computerized fire control upgrades. Tank crews were trained to rely on systems that could calculate range, lead, and trajectory faster than any human eye. The psychological impact on potential adversaries was profound. Even the threat of engagement carried an implicit guarantee of rapid destruction. Conventional forces could no longer ignore precision. It dictated strategy, deterrence, and diplomacy alike. The Soviets and later the newly formed Russian forces recognized this shift with a mixture of alarm and adaptation. Doctrines written in the 1970s, emphasizing mass, speed, and maneuver, were suddenly vulnerable to technologically augmented forces. Training emphasized old methods of concentration and aggression, Yet NATO's exercises had proven that superior fire control could render those advantages moot. The result was a doctrinal crisis. How do you plan for a battlefield where overwhelming numbers may be annihilated before they can engage? The implications extended to the political sphere. Military planners briefed politicians that any miscalculation could escalate conflicts far beyond initial intentions. Precision systems, while defensive in theory, allowed limited engagements to produce disproportionate effects. NATO's political leadership realized that conflict could no longer be measured merely in manpower or equipment. It had to account for technological edge, reaction time, and information dominance. The battlefield had become a strategic instrument that could shape diplomacy before a single shot was fired. In practical terms, this translated to a new form of deterrence. For the first time in armored warfare history, the knowledge that a smaller, technologically superior force could destroy a larger adversary altered enemy planning and risk assessment. Nations could hesitate, redraw lines, or avoid confrontation entirely. Not because of treaties or alliances, but because the consequences of misjudgment were immediate and precise. Fire control systems had evolved from battlefield tools into instruments of geopolitical influence. Exercises, simulations, and reconnaissance weren't just preparation, they were signals. NATO demonstrated capability without aggression, broadcasting lethal potential through silent dominance. Leaders understood that deterrence didn't require firing a single shell. It required demonstrating that every shot would count, every engagement was calculated, and every enemy formation could be neutralized before it could threaten. Technology became a language of power, spoken not with rhetoric, but with measured precision on the training ground by the mid-1990s. The strategic landscape had irrevocably changed. The era of the massive Soviet tank offensive was over. Armored warfare was no longer a contest of mass steel and human endurance. It was a contest of systems, coordination, and anticipation. Doctrine, tactic, and politics had merged. Precision dictated strategy, and strategy dictated policy. The Cold War might have ended, but the lessons of fire control would shape conflicts, deterrence, and military planning for decades to come. By the dawn of the 21st century, the battlefield had been transformed in ways few predicted decades earlier. The M1 Abrams, Leopard 2, and other Western main battle tanks were no longer just machines of brute force. They had become extensions of human calculation, precision, and information dominance. The lessons learned from fire control systems weren't confined to tanks or training grounds. They had rippled outward, reshaping doctrine, procurement, and even international strategy. The most profound legacy was psychological. For decades, adversaries had relied on mass, speed, and attrition to achieve battlefield objectives. Those methods had worked in countless historical conflicts. But against Western fire control precision, the equations had changed. A single well-trained crew, leveraging advanced optics, laser rangefinders, and ballistic computers, could engage targets faster, farther, and more accurately than an entire Soviet brigade could react. The perception of invulnerability, the sense that sheer numbers guaranteed survival, was shattered. Fear and caution replaced aggression, even in exercises, shaping decisions long before actual combat. Tactically, armored warfare evolved into a battle of sensors, software, and synchronization. The human element remained critical. Crews still needed discipline, focus, and courage, but their effectiveness was now amplified through systems. Combined arms coordination became non-negotiable. Infantry, aviation, artillery, and reconnaissance were all part of the digital web, feeding information to tanks that could act on it in seconds. Engagements were no longer linear. They were dynamic, fluid, and data-driven, with terrain, visibility, and timing calculated with unprecedented accuracy. The doctrine also left an indelible mark on military procurement. Western nations realized that quality and technological edge often outweighed quantity. Tanks and weapons could be fewer, but far more capable. Budgets shifted from mass production to research and development. From simple armor to integrated sensor suites, automated targeting, and networking capabilities. Lessons from the Cold War armored duels influenced designs for decades, setting a standard still visible in today's modern MBTs, drones, and network combat systems. Strategically, the implications were equally transformative. Nations without such systems were forced to reconsider traditional approaches. Massed armored assaults, once the centerpiece of offensive doctrine, became high-risk gambles. Modern adversaries learned that aggression could be countered not with sheer force, but with precision, surveillance, and anticipatory tactics. Wars became shorter, more lethal, and less forgiving of error. The calculus of escalation changed. A misstep in the age of precision meant near immediate annihilation of assets. Perhaps most importantly, the legacy of fire control precision changed how militaries think about deterrence. Armor wasn't just for defense. It was a tool for shaping enemy behavior. Knowing that one's formations could be destroyed before they engaged, adversaries altered deployments, hesitated in maneuvers, and sought alternatives. The battlefield became a chessboard of perception, technology, and anticipation, with an invisible hand of precision dictated outcomes as much as kinetic power. Yet, the story is not purely technical. It is a story of human adaptation, ingenuity, and foresight. Western fire control systems didn't win wars alone. They amplified decision-making, rewarded discipline, and penalized hesitation. They forced a reevaluation of age-old doctrines and proved that in modern warfare, systems often matter more than mass, and cognition can outweigh brawn. As the world now watches armor developments across continents, the shadow of this transformation looms large. Nations continue to invest in automation, AI-assisted targeting, and sensor fusion, extensions of principles proven decades ago. The Abrams, Leopard, and Challenger may be symbols, but the real victory lies in how they redefine the rules of engagement, deterrence, and military thought itself. In the end, the Cold War may have ended, but the war over how to fight, survive, and dominate through precision is ongoing. Western fire control systems didn't just change tank battles. They changed the very way the world understands armor warfare, and their legacy will guide strategy, policy, and military thinking for generations to come.